Hello everyone, I'm Jeffrey Snook Cosgrave, and today we're going to be going over the Komodo Dragon's nasty bite, fact or fiction. I initially set out to create a presentation on the bacteria inhabiting the oral cavity of the Komodo dragon, yet my research unveiled a more intriguing narrative than I had anticipated. The prevailing perception is that Komodo dragons possess exceptionally unclean mouths, relying on their hidden microbial allies to overpower large prey. However, the reality might challenge this commonly held belief. First, let's introduce our monster, the Komodo dragon, Earth's largest lizard, once roamed across the vast expanse of Oceania. However, today it stakes claim to only a handful of small islands within the Indonesian archipelago, with the most renowned being Komodo Island. This small gem is nestled amidst a chain of islands that separates the floor sea and the Indian Ocean. The Komodo dragon's present habitat is remarkably compact, the smallest among large predators. Their reptilian nature most likely plays a pivotal role in this, as their nutritional demands are comparatively lower than those of mammals of equivalent size. Recognizing the Komodo dragon's rarity and magnificence, local rulers and the Dutch colonial government initiated protective measures as early as 1915. And this flag with the little VOC is actually the Dutch East Indies flag. These conservation efforts, while significant, have limitations and do not prevent these dragons from occasionally harming each other. With that being said, juvenile dragons tend to spend the majority of their days perched in trees, a strategy to evade larger, less agile adults who might view them as potential prey. Komodo Island and beyond. The Komodo dragon, also referred to as the Komodo monitor, is a distinguished member of the monitor family, also known as Varanidae. Within this family, only one genus, Varanus, remains today. Notably, in close proximity to the Komodo dragon's habitat, you can find the second and third largest lizards, both of which are monitors as well. To the west, in Malaysia, right around Cameroon Heights, which would be right around here, we encounter the Asian water monitor, the second largest lizard in the world. And to the east, we encounter the crocodile monitor, as I am covering it up, but it's here in Papua New Guinea. And it is actually the world's longest lizard. However, it's worth mentioning that despite their impressive length, the crocodile monitors lack the substantial mass that Komodo dragons can attain. And just for a little bit of extra clarification, right above this island right here, we will find Komodo Island. My cursor's right over it. And subsequently, we would then find Komodo National Park. And it's crucial to clarify that while crocodiles and alligators are indeed reptiles and crocodiles are in the same area, it might be a little bit more helpful to point out that this is the Cape of York of Australia, and this is Darwin, the head city of the Northern Territory of Australia. So crocodiles are definitely here, and they're definitely in the area, but they belong to the crocodilian family and are not closely related to lizards, despite their shared reptilian classification. They exhibit significant differences. Now, let's talk about what is popularly believed with Komodo dragons. The prevailing notion regarding Komodo dragons is that their bite packs a formidable punch, as highlighted in Claudio Coffey's article in the March 1999 issue of Scientific American. Its tooth serrations harbor bits of meat from the Komodo's last meal, either fresh prey or carrion. This protein-rich residue supports large numbers of bacteria, which are currently being investigated. They have found some 50 different bacterial strains, at least 7 of which are highly septic in the saliva. If the deer somehow maneuvers away and escapes death at this point, chances are its victory and it will nonetheless be short-lived. The infections it incurs from the Komodo bite will probably kill it within 1 week. Its attacker, or more likely other Komodos, will then consume it. As scary as that sounds, that was actually based off of one of the first observations originally made by Walter Affenberg, a researcher from the University of Florida who led one of the first pioneering expeditions of Komodo Island to study its iconic dragons. Affenberg's most notable achievement is his 1981 publication, The Behavioral Ecology of the Komodo Monitor, a culmination of his extensive time spent on the island. Affenberg was the first to propose the idea that Komodo dragons might possess harmful oral bacteria as a means to subdue larger prey. However, it's essential to note that this hypothesis was based solely on his observations and lacked concrete evidence. Nonetheless, when this notion emerged in the 1980s, it gained widespread acceptance and has persisted in common belief, even today in 2023. I would even go as far to believe that someone watching this video most likely believes that this is true prior to watching the video. As you can see, this long-standing belief has prompted intriguing research, particularly concerning the aftermath of a Komodo dragon bite, typically sustained by animal caretakers at zoos. Such incidents often induce panic due to the belief in the dragons harboring harmful microbes within their jaws. Consequently, victims are closely monitored and frequently subjected to potent antibacterial treatments. Nevertheless, the conclusions of these case reports generally do not support the notion of a particularly perilous situation to begin with, according to healthcare professionals. I would like to note, while this case in particular didn't really seem to have much issues, this case did report a big issue with getting the bleeding to stop, and it took over 30 minutes to have the wound to stop bleeding. Now, let's tackle the myth itself. At first, this concept faced scrutiny when researchers examined the oral microbial populations of Komodo dragons in the wild versus in captivity, revealing startling disparities. Wild dragons boasted mouthfuls teeming with menacing microbes, E. coli being the most prominent, whereas captive dragons displayed no concerning microorganisms. This discovery spurred researchers like Brian Fry, renowned as the Venom Doc, to delve deeper into this matter. Fry's investigations indicated that Komodo dragons were proficient at capturing smaller prey, such as deer and pigs, but struggled when facing larger non-native prey. The introduction of the water buffalo to Komodo Island by humans has led to a thriving wild population of water buffalo. When confronted by a Komodo dragon, the odds of a successful takedown of a water buffalo are relatively low. In most cases, the buffalo manages to escape with only a few bites to show for the encounter. In their natural habitat, water buffalo would retreat to marshlands for safety, taking refuge in bodies of water. However, on Komodo Island, the absence of marshlands led the buffalo to seek shelter in smaller water pools scattered across the island. In these crowded pools, the buffalo defecated and stood, inadvertently exposing their open wounds to potential bacterial infections. It's worth noting that wild dragons also acquired their oral bacteria populations from the same water sources, dispelling the notion that Komodo dragons employ bacteria as a form of venom, a story seemingly fabricated by humans. Further substantiating this view, a study conducted by Hyde et al. Demonstrated that Komodo dragons extensively share their skin, salivary, and fecal microbiomes with their surroundings. Notably, no single species of microbe was consistently identified in all dragons that samples were taken from, and the variability in bacterial populations between individuals was just too significant to suggest the presence of an evolved trait. The most compelling evidence against the bacterial venom hypothesis emerged from a comparison of the oral microbial populations of captive Komodo dragons in the United States, which surprisingly exhibited lower bacterial levels than those commonly found in captive mammalian carnivores like lions. The Venom Doc, aka Brian G. Fry's big discovery. Fry, unsatisfied with existing explanations, persevered in his research on these intriguing reptiles. It wasn't until he conducted a study comparing Komodo dragons with an extinct giant lizard that he stumbled upon a groundbreaking revelation. To facilitate a more precise comparison of the two creatures' skulls, Fry employed MRI technology. However, what he uncovered during this process exceeded his expectations. Komodo dragons possess venom glands. Yes, you heard me right. Their predation strategy involved a grip, rip, and drip tactic, where the dragons would bite down with serrated teeth and utilize their powerful neck muscles for pulling to create gaping wounds. And just to be clear, they do not have a strong bite force, but they have a very strong pull force, and they can take a lot of pulling. And that pulling would help create these big gaping wounds. The venom, having oozed out of the venom glands, then accelerates blood loss and can induce shock in the prey. Next, let's explore these venom glands. When the Komodo dragon clamps down with its powerful jaws and serrated teeth, it exerts pressure on its gums, propelling toxins through the venom ducts and into the prey through the bite. In contrast to venomous snakes with hollow fangs, or venomous lizards like the Gila monster with grooved teeth for precise venom delivery, the venom of the Komodo dragon oozes out of their mouth while they bite. The venom is particularly hazardous due to its anticoagulant properties. Once bitten, the wound continues to bleed, leading to a drop in blood pressure that ultimately leaves the victim in a state of shock. In this vulnerable state, the dragons capitalize on the opportunity to consume the prey. And remember our one case report where the one victim was unable to stop the bleeding for over 30 minutes. The exact reason why Komodo dragons possess this venom remains a mystery, given their size is sufficient to handle the local deer and pig populations without relying on venom. Nonetheless, some researchers speculate that the recently extinct dwarf elephant that is local to the area may have been a prey item that influenced the evolution of venom and the large size of Komodo dragons, if it constituted a significant part of their diet. This is still just a lot of theory. The composition of the venom used by Komodo dragons is not yet fully understood, but is thought to be similar to that found in venomous snakes. The primary component of the dragon's venom is an enzyme from the superfamily phospholipase A2, or PLA2 for short. Although the specific enzyme is currently unidentified, PLA2 catalyzes the hydrolysis of phospholipids, typically by breaking the bond between the second fatty acid tail and the glycerol molecule. And you can see that right here. This is the pathway that this one would follow. This serves as an anticoagulation factor, preventing the wounded animal from forming blood clots at the site of the bite. As a result, the animal continues to bleed until its blood pressure drops to a critical level, inducing shock. This occurs because the PLA2 inhibits one or two steps in the blood coagulation cascade. In conclusion, my investigation, initially focused on the oral bacteria of Komodo dragons, has uncovered a captivating story that challenges long-held beliefs about these remarkable creatures. While the prevailing perception suggested that Komodo dragons rely on their oral bacteria to subdue prey, recent research has cast doubt on that notion. Brian Fry's work has revealed that Komodo dragons employ venom rather than bacteria. This venom, discovered through advanced imaging techniques, contains anticoagulant properties that prolong bleeding and induce shock, aiding the dragons in securing their prey. In this journey together through the world of Komodo dragons, our understanding of their behavior, feeding strategy, and the role of bacteria and venom has hopefully evolved. I hope everyone can take the time to reflect nature's complexities as they continue to captivate the science community, inspiring further exploration and discovery from each and every one of us. Thank you very much. And if you made it this far, these are my sources. Thank you very much.